Okay guys, in this video we're going to look at how to solve exponential equations, and those of you who do not like using the calculator, setting equations equal to each other and trying to find viewing windows will now be able to solve them without having to do this graphically and finding points of intersection. So let's go back and review for just a minute. Remember that we talked about inverse functions, and we said that if you have the graph or the function y equals 2 to the x, the inverse of that would be x equals 2 to y, 2 to the y. Then we also learned that we could rewrite that as y equals log base 2 of x. And remember that we talked about I could take exponential and logarithmic forms and switch between the two of them. So really I could rewrite this as 2 to the y equals x. So just reviewing where everything comes from. Also remember that previously when we talked about inverses, one of the ways we could prove that inverses were actually, or that two functions were inverses, was to look at their compositions. If we did f of g of x and g of f of x, both of those had to simplify down to x. So that's going to be really important for us to realize the way that notation is going to look. So we're saying that f of x is log base a of x. So it could be log base 2, log base 10. And g of x is a to the x, 2 to the x, 10 to the x, e to the x. Let's first of all look at what f of g of x would look like. Well, remember, that means we're going to take g and put it into f. So we're going to put a of x in every time we see an x. So that looks like log base a of, and then we replace the x with a to the x. So what you really want to remember is that when you have a log base a and an a to the, they're going to cancel each other out and just give you that x. And that's how we end up solving exponential equations. So let's look at how to solve a few of these. So let's say we have 2 to the x equals 8. Well, first thing I could do to get rid of 2 to the opposite of an exponential or the inverse of an exponential is a logarithm. So I'm going to take log base 2 on both sides. Now, when I do that, log base 2 of 2 to the x, those are going to cancel and give me just x. And then I need to ask myself, can I find log base 2 of 8? Well, remember, that means 2 to the what gives me 8. And that answer is 3. So then my answer for that equation would be x equals 3. And if we go back and look, that makes sense that 2 cubed is equal to 8. So let's look at another one. We have 3 to the 2x plus 1 equals 7. We want to get that x by itself. So I need to get rid of this 3 to the. So to get rid of 3 to the, I do log base 3. But what I do to one side, I have to do to the other. So I'm going to have log base 3 of 27 on the other side. But then log base 3 of 3 to the will cancel and just give me 2x plus 1. Then I need to ask myself, can I do log base 3 of 27? 3 to the what gives me 27, and that's 3. And now I've just got a linear equation to solve. We would subtract 1 and get that 2x would equal 2. Then we could divide by 2 and get that x equals 1. All right, another one. This time we're not going to be able to evaluate our logarithm the way it starts. So let's say we have 7 to the 5x plus 3 equals 18. I need to get rid of this 7 to the because my exponent is in my, or my variable's in my exponent. So I'm going to do log base 7 of 7 to the 5x plus 3 equals log base 7 of 18. But then log base 7 of 7 to the will cancel, and I'm going to get 5x plus 3 equals, and then I have log base 7 of 17. Well, for right now, I'm going to solve this without my calculator, and then we'll come back and we'll do it with a calculator. So we're going to leave that as log base 7 of 18. Now I'm trying to get x by itself, so I would solve that equation by subtracting 3. That would give me 5x would equal log base 7 of 18 minus 3. Now notice I cannot make that log base 7 of 15 because one of those constants, the 18, has a log with it, so they're not common terms. I can't subtract them. Then I would divide by 5. And so x would be log base 7 of 18 minus 3 divided by 5. Now, you are going to have some problems like this on the test where you'll not be allowed to have a calculator, and then there'll also be places where you do have a calculator. So if you want to grab your calculator, let's look at how you would solve that. Well, remember that to evaluate log base 7 of 18 by itself, you're going to want to do log of the tall over log of the small. So we would do the log of 18 divided by the log of 7. Now you might want to go ahead and push enter at this point in your calculator, and that's going to give you 1.485 and other decimal places, but out to 3 decimal places, that's where we're at. Then the next thing I'm going to need to do is subtract off the 3. So I could put minus 3 and then push enter. And then the last thing is divide by 5. And so when I get done, my final answer turns out to be negative 0.303 if I round to 3 decimal places. Let's finish up with just a couple more examples. So let's say we have 12 to the 3 minus x plus 8 equals 100. So I'm going to subtract the 8 first and get 12 to the 3 minus x would equal 92. Now, I have 12 to the, do not divide by 12. This is not a multiplication problem. That's where a lot of kids on these problems will mess up. So what I want to do is I want to do log base 12 on both sides. So I'll do log base 12 of 12 to the 3 minus x equals log base 12 of 92. And again, I'm going to leave that like that for right now. Then we'll use our calculator in a minute. Our log base 12 and 12 to the cancel. I get 3 minus x equals log base 12 of 92. And then I want to get my x by itself, so we'll subtract 3. So I have negative x is equal to log base 12 of 92 minus 3. And then since I want just x, I would divide everything by negative 1. And now that would be my final answer if I'm not using my calculator. If I am allowed to use my calculator, and again, you might want to get your calculator at this point and practice, make sure you can get this in. To get log base 12 of 92, we do log of the tall, so log of 92 divided by log of the small, which would be 12. Let's go ahead and push enter there if you're not sure about putting this into the calculator in one step. Subtract 3, push enter, and then divide that by negative 1. And you should get an answer of 1.180. Now, if you want to put all of this in one step, what you're going to need to do is put parentheses around your problem. Everything in the top has to have a set of parentheses, and then everything in the bottom. So I could do parentheses, log of 92 divided by log of 12 minus 3, and then divide that all by negative 1. And that should give me the same answer. So if you want to try that with your calculator, you could double check it. All right, so let's wrap up with a problem on e to the. So remember that the inverse of an e problem is a natural log. So to get rid of an e to the, I'm going to take the natural log of both sides. So we're going to get the natural log of e to the 4.6x minus 1 equals the natural log of 12. Now natural log and our e to the will cancel, so that gives me 4.6x minus 1 equals the natural log of 12. I'm not expected to know the natural log of 12. You only have to know 2 natural logs. The natural log of e is 1, and the natural log of 1 is 0. So we're going to get this x by itself. We'll add 1. So 4.6x equals the natural log of 12 plus 1. Again, I cannot make that the natural log of 13 because those aren't like terms. Then I would divide by 4.6. So my answer is that x equals the natural log of 12 plus 1 divided by 4.6. Then I could put that into the calculator. So you could either do that in one step and put parentheses around your top, parentheses around the denominator, or you could break it up. You could do the natural log of 12 and then plus 1 and then divided by 4.6. And I'm getting 0.758 when I work it out that way. Now we are going to do one word problem so that you can see how you can now solve these without having to look at them graphically. So you're going to invest $1,000 at 6% compounded continuously. So I already know the formula I want to use is A equals P e to the RT. You want to end with $5,000, and I want to know how many years must you leave the money in the bank. So let's look at what we know. The $1,000 is what we're starting with. That's the P. The 6% is my R, and the $5,000 is my A. So I have this equation. 5,000 equals 1,000 e to the R. I don't know what, oh, I actually do know what R is in this case. A lot of times you're solving for R. And then I don't know what T is. So we'll go back and put in that R was 0.06 T. So I'm trying to solve for T. So what I'm going to do is now I can solve this equation algebraically. Up to this point we've had to graph these. We would put this in Y1 and this in Y2, guess at a viewing window for most of you, then try to get the point of intersection. Well, now we don't have to do that. We can actually solve this equation. So we'll start by dividing both sides by 1,000. Now this side's easy. We'll go ahead and get that that's 5 equals E to the 0.06 T. And I want to get T by itself. So to get rid of an E to the, I'm going to do the natural log of both sides. But the natural log and the E are going to cancel. So I have the natural log of 5 equals 0.06 T. And I can divide both sides now by 0.06. And when I do that, let's go ahead and put that in the calculator. I'll just take the natural log of 5, divide by 0.06, and I get 26 point, and since we're looking at years, let's just go to the nearest tenth, 26.8 years. So if I started at $1,000 and wanted to get to $5,000 at 6%, I'm going to have to leave that money in the bank for almost 27 years for that to happen. Now my last two slides are just going to be your practice problems. So this is kind of like your homework. I know some of you may not have internet access or you may not want to print out the problems. So here are a list of the problems. There are 10 of them. The first 5 you are to solve without a calculator. Leave them in those ugly forms that we looked at, like you might have an answer of log base 2 of 12 minus 8 over 7. Just leave it like that. Don't worry about it. You might want to take a minute, pause the video, work on those problems, and then when you restart, you'll have the second set of problems. In this set of problems, you are allowed to use a calculator. And what I want you to do is these first 4 on 6 through 9, give me the answers to 3 decimal places. But if you'll read through the 10th one, it says you're only to round to the nearest 10th, which would be 1 decimal place. Okay, so that's the only one that you will not take out to 3 decimal places, because your question is what's the interest rate you're going to want to know.